I'm here today to tell you a couple stories about optimizing things for our Android Wear. And well, first off, a little bit about myself. I'm an engineer on the Android Wear frameworks team. I spend a lot of my time doing battery life optimization, among some other things. And I've been developing for Android since the dark days of Cupcake, many, many moons ago. And yeah, I guess the only other thing to mention, I'm Canadian, so you see any funky spelling and so on and so forth, that's because, that's how you spell English, and it's real Queen's English. And yeah, so, well, first off, the most important part about optimizing your Android Wear is, well, battery life. Pretty self-explanatory. The worst thing you can possibly have on a watch these days is one that has a blank screen. We all kind of like, and our users all like, having a screen that's always on, it's always got information, and you can always, glance at it and see what's up. So there's a couple challenges when it comes to optimizing for battery life. And, well, the screen being on all the time is actually a pretty big problem. To actually have the screen on, we have to make a lot of compromises. And there's actually, the watches are pretty good. They've got enough performance to run Android. It's got enough performance to run full videos. And that tends to be a problem, because if you run full videos on your watch, they don't tend to last very long. So yeah, there's quite a few things we have to deal with. If you want a very, very powerful device that can last a long time, you could strap your phone to your watch, to your wrist, but that's also not very pretty. So yeah, we have now 3 tales of battery life. These are sort of cautionary tales, sort of campfire ghost stories of things that have, well, let's not say happened, but lessons that we've learned. So first I want to start off with the watch face. So this watch face wants to be really, really, really pretty. And how do you make a really pretty watch face? Well, we start with like gorgeous animations. And I'm talking like animations that have a slowly moving second hand that sweeps gracefully across the screen. It's got cogs basically taking away the background. Gorgeous, gorgeous watch face. Well, there's a big problem with that. Animations are very powerful. They're great. They're gorgeous, but they're really power hungry. If you have an animation that runs every time your watch face shows up from its ambient mode, so every time you look at it, it does a little animation. Yeah, that's perfectly fine. Half a second animation, whatnot. But if you have to keep an animation going all the time, well, the application processor is going to have to calculate all the pixels moving. It's going everything on your watch is running at full speed. Your watch is going to heat up, and that drains a lot of battery life. So probably want to avoid having animations that run all the time. So you want to pick the best spots for animation. Well, the other problem with animations, and Android Wear actually, well, on phones, you don't really get screens that change in the refresh rate very much. They're almost all universally 60 hertz. So we target 60 frames per second, and Bob's your uncle. On watches, because we're using really small screens, very power-efficient screens, they're only guaranteed to be operating at 30 hertz. And this is sort of even more compounded by the fact that some screens work slightly faster. Some screens may even go all the way up to 60 hertz. But they're only guaranteed to work at 30 hertz, so your animations actually have to look good at 30 frames per second, which isn't a big deal, but if you're not aware of it, you will suddenly pull out your watch and go, this animation doesn't look good. No matter what I do, no matter how fast I render it, no matter all the little hacks I do, it still looks like it's rendering at 30 frames per second. That's not like something broken. That's actually how fast the hardware can possibly render, because the screen is very energy efficient. That said, you still want to hit 16 millisecond frame rendering target that you need for 60 frames per second, because other watches will have better screens. So your watch may not be great, but have the greatest screen refresh rate, but your other users may do. And finally, somebody will always ask you, you know what, these watch face, the animations, they're great and all, but we can save more battery life if we turn on hardware acceleration, right? And we get asked this basically once a month. Somebody will ask, hey, can we turn on hardware acceleration? It's going to save battery life. So in this watch face in particular, we actually sat down and we measured the current when we turn on hardware acceleration. And you have a 50% increase in battery drain, which actually kind of makes sense. When you turn on hardware acceleration, you're actually using more silicon on the actual device. Normally, things that wouldn't be running would now be running because they're accelerating your graphics. So yeah, if you need hardware acceleration, you should totally use it to get better frame rates. But if you don't need it, turning it on won't help your battery life whatsoever. So something to keep in mind, that it's not magic that you sprinkle on top of whatever animation you're doing. It actually has costs involved in it. So this gorgeous animating watch face had this other thing they wanted to do. And they wanted to have photos. And specifically, they wanted to pull photos from the actual phone that the watch was paired with. And you have giant bitmaps that they wanted to render in a screen. So they had really, really big bitmaps that sucked up a lot of memory, which became a bit of a problem because these devices don't have a lot of memory on them. They have about half a gigabyte of memory, and that's it. Now, that's more than enough because the screen with the biggest resolution is currently the Huawei watch, which is 400 by 400 pixels. Not a lot of pixels to push. You don't need gigantic, 15 megapixel photos, but they sent it over on the Bluetooth radio, a radio that needs to slowly send every byte on both from your phone to your watch. So now you're draining battery from your phone, you're draining batteries from your watch, and that didn't work out very well. And we'll just say that once we actually got the phone to actually shrink the images beforehand and send it over that way, battery life became a lot better. Things sent a lot faster for some odd reason. Apparently, if you send less data over, it sends a lot faster. Watch faces are always loaded on your watch in the sense that every time your watch goes back to the watch mode, you see a watch face. Seems obvious, but that does mean that anything that is running on your watch face is loaded in memory, which means that if it takes up a lot of memory, the application you just used is now garbage collected and stopped. So it means that you want to be a good citizen of Android and actually not use too much memory if you don't have to, so that other applications won't randomly shut down every time you fire and take longer to boot up every time. So taking all these things into account, we ended up with a watch face that actually was, fairly power efficient on many, many devices. But, we pulled it up on certain devices, and suddenly the battery life jumped up. The battery life jumped down, the battery consumption jumped up, and it was really strange because it was only a certain class of devices, and those are specific devices with OLED screens. OLED screens are not like LCD screens. We have watches that implement both. So we have watches that have OLED screens, and we have watches that have LCD screens. And OLED screens have to emit light. They emit light from the individual pixels, which is fairly obvious. But that means that if you go with a darker palette, it needs to emit less light, and therefore it takes less battery life. On an LCD screen, it doesn't matter. So if your watch face is completely, bright, it's got lots and lots of colors in it, it's going to cost the same amount of battery life as if it's completely dark. Well, similar amounts. On OLED screens, a dark background saves you a lot of power in comparison to, say, a completely white background. So something to keep in mind. But if you take that into account, then you will have similar performance across both, watches that have LCD screens and OLED screens. So with that, this is basically the, rough ways to actually make a watch face not suck up, say, 4 extra hours of battery life off your watch. But we don't always have to use a watch face. It's a full Android system. We have apps. We have apps that we can run. So a classic app that we run is the fitness app. So this is the fitness app in which, first time I got it, you pull it up, I click on the icon, and I wait, and I wait, and I wait, and I wait, and I wait for a long, long while for it to load. By a long while, I actually mean like about a second and a half or so. Look, whenever I'm using a watch, you use it for about 5 seconds. You pull it up, you tap, tap, look at some information, it's done. If your app takes a really long time to start up, it's not ideal. You're going to suck up a lot of users' time just waiting for things to boot up. So because you want to use the watch as little as possible, or rather for users to use the watch as little as possible, you want the watch to go back to sleep. That saves power. So you want things to load quickly. So the best way of making things load quickly is don't load things that you don't need. So yes, don't do things you don't need to do, like all Android apps, but I mean, even things like loading classes can take a while. Loading big images can take a while. Loading data from the SD card that you could defer later on could take a while. So one of the things that's important about watches, more so than phones, because phones, you get a splash screen, I've already pulled my phone out, I've unlocked it. Taking an extra second, not a big deal. Taking an extra second for your watch to load up, actually pretty big deal, especially if I'm only using it for a couple seconds to look up some information. So, and of course, as I mentioned before for watch faces, if you use a lot of memory, you'll kill other applications. And if you exit your app and if you use a lot of memory, the system will also remove your app from memory, which means the next time you open it is also going to take longer. So you want to actually keep your memory usage low, even for an application. But, well, so for a fitness app to actually do any work at all, it has to use sensors. If you don't use sensors, the fitness app doesn't really do anything. It just sits in your watch and probably tells you some information. So the nice things about Android Wear watches is that they have a full suite of sensors, just like Android, most Android phones. And picking the right sensor is also actually really important. Accelerometers are great. I love them. They use very little power. And for almost all our watches, our accelerometers actually have some built-in memory inside them that allow them to actually operate without the application processor in your watch from doing anything, which means that it actually takes a lot less power to gather data. So you don't have to be running an application completely while collecting minutes of data. And that's really important because that actually lowers the overall power use if you use a accelerometer. A gyroscope, on the other hand, doesn't have that neat feature. It doesn't batch any of the data. And more importantly, accelerometers use about a tenth of the power as a gyroscope. So if you're doing your own motion algorithm, if you're doing your own gestures and playing around with that, consider just trying to get everything to work with an accelerometer. Like Android, you want to use sensors as little as possible, by which I mean you don't want to use it if you don't have to. So you can do things like lower the sample rate. If you lower the sample rate, you can actually batch up more samples of data before it actually runs out of memory and sends it all to your application to work with. And of course, you want to turn off the actual sensor if you're not going to use it. There may or may not have been issues where an application would turn on a sensor and then just keep the sensor on indefinitely. Bit of a problem when you're trying to save power, especially if you're trying to sample data at the highest possible rate possible. So you want to be very, very careful in dotting your I's, crossing your T's, shutting down things when you don't want to. So once you've gathered the data, one of the things that all fitness apps like to do is they like to synchronize with some server somewhere. So they use a network to send some data. So the important thing about sending data, again, use as little data as you possibly can get away with. So one thing not to do is to send all your logging data about how to send network information as a part of network information to send back. That tends not to work very well, especially if you end up in a situation where, say, you send 100 kilobytes of data and that gets followed by 200 kilobytes of logging data. Something to avoid, perhaps. But the timing of sending network data is actually pretty important, too. So say I'm accessing information from your phone frequently. I have to do it quite a bit. And every time I do it I only collect like 2-3 bytes. Not a lot of information to send, right? So I'm following, send as little as I can. But every time I ask for information, it's, I have to ask every 10 seconds. Every 10 seconds, I got to send a couple bytes. Well, the Bluetooth radio has to turn on, is always on, which is great. Bluetooth radios on your watch is almost always on, unless airplane mode is turned on. But just because it's turned on doesn't mean it's operating at the same power. If it's idle, it doesn't use much power at all. If it's not idle, it actually has to spend time to ramp up, has to connect to your phone. It's connected to your phone, but it has to actually tell your phone, hey, I'm about to start talking. That takes power. And then has to send the information, which takes more power. And then has to shut back down, which actually takes even more power. And all those things takes a couple, a half second to start up, half second to shut down. And if I'm only sending 2 bytes of data, that's maybe about 10 milliseconds. But your 10 milliseconds of data being sent, that should cost a whole second of the Bluetooth radio turning on and off. And if I do that every 10 seconds, that suddenly becomes a huge problem. So what you want to do is you want to batch all those data. So usually you don't really need immediately to the second the data from the watch, from the phone to the watch. So you want to batch it so that you maybe want to send it once a minute. And why I mention once a minute is, well, your watch actually has to do something every minute, especially when your watch face is on. And that's to update, your watch face. Every minute, when your time ticks, your watch face updates. And if you're going to have to do some network synchronization, you want to do it when it actually ticks in during that time. You want to do all that work at the same time. You want to dogpile together and then stop. So if you develop a watch face that needs data to be synchronized every minute, maybe you want to synchronize 5 seconds beforehand instead of, say, trying to keep the entire watch on by synchronizing at random frequent intervals. So sending a lot of little things can be really bad. So you want to batch it together, but you still want to send as little as possible. So the other thing that is really bad is listening to intents that are frequently dispatched, by which I mean we may have encountered a situation where a certain fitness app was sending data every time you turned the screen on, by which I mean every time you look at your watch, it would send data to the phone and then request it on the phone. And then every time the screen turns off, it would do the exact same. And if you wear an Android Wear watch, you'll note that you actually look at it every now and then a lot. Every time you look at it, it would suck up a tiny bit of memory, a tiny bit of energy, and do it again. So it's not the greatest thing in the world to do that. It may or may not have dropped battery life a couple hours. All these little things add up over time, especially if you operate every time any minor thing changes. So please don't do that. Please avoid intents that are dispatched a lot. And if you absolutely have to, please stop using them if you don't need them anymore. One of the things that a lot of people don't forget is that you can actually disable listeners, especially even broadcast receivers that you registered in your manifest. You can disable them in code when you don't need them. So something to keep in mind. You don't always have to run when you're listening for certain intents, even if it's set up in your manifest. So that's basically it for a fitness app. We have an app that efficiently gathers your fitness data. We have an app that actually sends data in a very power efficient way. So I'm walking down the street, done my run, I want to go home. One of the things that it's really nice for me is that, getting transit information. So I'm going to talk about the transit app that, I got. I popped on my watch and I said, hey, great, it's got a new transit app. I tap, it opens up, tells me the time the next bus is coming. All right, okay, I got to run to a bus stop now. And I start running and take a quick look at my watch again after a minute or two. The app is gone. So me being a guy that likes my lunch, I said, hey, it'd be great if you could just keep telling me that information. Look, if I'm looking at the transit information, odds are I'm occasionally running to the bus stop in a hurry because I woke up late. So the person said, "Oh, sure, we can keep the screen on," by which he meant he kept a full wake lock on, which meant the screen was permanently on, full brightness the entire time. It's not. Please don't do that. It means that the application processor is running really, really fast. It drains a lot of energy when it does that. The screen is on. It also doesn't work really great when your screen is on at full blast. Wayne earlier talked about a couple modes that you could use. So interactive mode, when we call something in interactive mode, that's when you can touch the screen. You can, it's got the touch sensors, you can tap buttons, and so on and so forth. That's what happens when you keep a full wake lock. But in Android Wear, we introduced something, we call it ambiactive mode. What that means is that your app is running, but the screen has turned off. By off, I mean in the sense that the screen isn't active. This touch screen is off. You can't touch buttons. You can touch the touch screen, and it will switch it back into interactive mode. Now, that's actually pretty great, because what that does is that your app can actually give the system a particular image to display on the screen. So you can be like, you can turn all your text to a certain color, say white, turn your background to black, and the watch will just keep that image on. It's great for stopwatches. It's great for transit apps. It's great for keeping power, because your screen no longer has to be running at full blast. The system doesn't have to be operating at full blast. The actual system actually turns off a lot of the display, the silicon involved with displaying, because it doesn't have to actually receive any new information now. All it has to do is just display that one image that you've pushed to the screen. So that's great. You can turn on ambiactive mode. I can now use the actual app and see my transit time. You can update the image every minute or half a minute or whatnot, and it's useful. And it's actually one of the things that's most useful about this device. You can actually create applications that can take over the entire screen and be used the entire time without creating your own watch face. Because I may like my transit app, but on a day-to-day basis, I don't need it to be my main watch face, and I don't want to keep switching my watch face. I like my watch face. It's pretty. It has nice colors in it. The other thing about ambiactive mode is that the 5% screen use is still important. OLED screens have a very bad tendency to burn in, by which I mean back in the olden days, we had CRT screens, we had plasma screens, and if you kept them with the same image on the screen, or kept the Weather Channel on or MTV on, it would burn in. You would have a burn-in ghost of an image. OLED screens actually have the same problem. It's not a big deal on phones, because chances are your phone aren't going to be stuck at the same image and turned on all the time. But the problem with watches is that, you got your watch face. They do that. You have the same, time ticks and stuff all over it. So you only want to use a very, very small bit of the screen, and we do our own magic to shift the actual image around in order to combat burn-in. So screensavers are kind of back. So yeah, that's something to keep in mind whenever you're doing ambiactive. While the system can definitely hold a screen that's completely bright on, it's not great for OLED screens because it wears them out. So the transit app, we ended up getting rid of the ambiactive problem. It doesn't hold a wake lock anymore that keeps it on at full screen all the time. So we were looking at other ways to improve it. And one of the problems that we were having was that we found out that it was hitting the network a lot. By which I mean every time you would move a couple hundred meters, it would refresh all the traffic data, or the transit data, because, we had another, we got to another bus stop and it's got new data to update you. So, this is great for certain applications. But for applications where your data changes a lot, it's not so great. I don't I love my transit, but I don't actually need to know when the next bus stop is all the time. I kind of just want to know when I'm, trying to commute home or something. So your users may not always want to use your app. You, surprisingly, may not always be the most important thing on the watch. I mean, I know it's surprising that, whatever application that we're developing isn't the greatest thing in the world, but data that gets stale and you have to load again and again and again, not so great. You may want to actually start loading the data whenever the user opens up the application. Now, that does mean that it is not as responsive as we possibly want the actual application to be. But that is something that, it's a design decision. We have to sort of work with that and decide to take whether or not taking up more of the user's battery life overall is good, or whether or not being slightly less responsive is good. So we err towards the side of an on-demand synchronization model. So when the user wants to actually get the data, then provide it. The other thing to sort of, going back to the fitness model, you want to synchronize maybe once an hour or so, not every time the user takes a couple steps. Seems obvious in retrospect, but you can usually get away with it when you have a giant battery strapped to, say, a phone-sized body. The luxury of doing synchronization like that is not so much when it comes to having a small battery on a wrist-mounted device. So with a transit application, the other thing that's really important is, of course, for it to get location data. Without location data, it can't really tell me where my bus stop is. So the problem with asking location data is that it's kind of crap for both the phone and watch. So you could grab location data from the GPS. We have one device right now, that's the Sony Smartwatch 3, and it has built-in GPS, and it's pretty much just as bad as when your phone uses the GPS. It takes up a lot of power. It's actually kind of a bit worse because the battery inside a smartwatch is smaller than a phone. Surprise, surprise. So GPS is even more expensive when it comes to how much battery life it drains from your device. But even grabbing from the network is also expensive. Your phone actually talks to your watch and tells it what the actual location is, because, of course, your phone has a bit more buffer when it comes to grabbing your location. Your phone also has a cell radio, and we can do fancy stuff with that to grab your location. But when you use your Bluetooth radio to send information, it drains battery life from the phone. It drains battery life from your watch. And if you say, grab the location information every 5 seconds, assuming that, it'd be just like grabbing it from a phone, it may drop their battery life by 2 or 3 hours. I mean, I'm not saying it's a terrible idea, but maybe you should avoid grabbing location data every 5 seconds. 1 minute's great, maybe 5 minutes. Maybe only grab it when you absolutely, positively have to. But just, certain things to keep in mind whenever you're grabbing location. It's not exactly free. And on a watch more so, it can drop your battery life by a very, very substantial degree. So, I know it's a bit early, but this is basically it for my tales. I kind of have a couple themes that I think are I've sort of harped on quite a bit. You don't want to do much, or rather, you want to do everything you can to make a good user experience, but you want to use everything as little as you possibly can. Use less sensors, don't grab as much location data, use the screen as little as possible, be conservative in your animations. It's, when you work more with Android Wear, you kind of find it's kind of like an Android phone. Like everything that impacts an Android phone in terms of battery life also impacts Android Wear. I mean, they're pretty much the same device. But because of the smaller battery, because we want small, nicely sized wristwatches as opposed to giant, cuffs on our wrists, any little drain is amplified in the overall battery life of the device. So you want to be really, really careful whenever you make decisions on whether or not an extra feature is going to be a very bad impact on your user's overall battery life. And if you have to do certain things, like sending network information, getting sensors, sort of batching everything together is great. You want a dog pile to get all your work together and then allow the device to go back to sleep. So sort of the overarching feature is you want your device to sleep as much as possible, because then it can last as long as it can. So that's basically it for my talk. I have my Twitter handle up there. You feel free to sort of message me. I can talk on and on and on and on about all the different little things we can talk about battery life, but that's basically the things I want to sort of talk about. And my colleague, Wayne, is doing a code lab on Android Wear development, if you want to get your hands dirty on that. And he's just at the code lab room, I think, like over there. And yeah, I'll be here to take questions.